Our group will present Scenario 1, the fume hood bypass. In this scenario, a bottle of concentrated HCl is safely stored in an acid cabinet. At this stage, it is considered a hazard because it has the potential to cause harm. However, when a student opens and pours the acid on an open laboratory bench, harmful HCl vapors are released into the air. This creates a high risk of inhalation for everyone in the laboratory. To better understand this scenario, let's first look at the definition of hazard and risk. A hazard is anything that has the potential to cause harm, injury, illness, or damage. Next, risk is the likelihood that a hazard will cause harm based on the level of exposure.
In this scenario, the hazardous chemicals is concentrated hydrochloric acid. According to safety data sheet, it carries the signal word danger because it has the potential to cause serious harm. HCl is hazardous because it is corrosive to metal, cause severe skin burns and eye damage, and may cause respiratory irritations. These hazardous properties are inherent, meaning they exist even when the bottle is tightly sealed. However, the risk is very low because the bottle is properly stored in an acid cabinet, no one is handling it, no vapors are released, and there is no human exposure. To conclude, a hazard is the potential to cause harm, while risk is the likelihood of harm occurring through exposure. Since the HCl bottles remain sealed and safely stored, the hazard is present but the risk is still very low. The next sessions will show how exposure turns this hazard into a risk.
Now, let's take a look at the short video. Can you guess why the situation is risky now? Hazards and risks are always related to each other. In the video, the student carried out several unsafe actions, including remove the acids from the cabinet, choose not to use the fume hoods, pour the acid on the open laboratory bench, and also no PPE. This action does create a high-risk conditions, which means that the acid vapor now escape into the laboratory and create exposure to the nearby students. In short, when hazards comes together with the exposure, risk tends to occur.
In this section, we focus on the exposure to hydrochloric acid vapor and why it is a serious risk in the laboratory. When hydrochloric acid is poured on an open bench, HCl vapor are released into the surrounding air. This corrosive fume can easily be inhaled by laboratory users nearby, increasing the chance of harmful exposure. Once inhaled, the vapor can cause several health effects. These include eye irritation, such as redness and watering. It may also lead to respiratory irritation, including coughing, sore throat, and difficulty in breathing. In most severe cases, direct contact or high exposure may result in chemical burn to the skin. Therefore, uncontrolled exposure to HCl vapor significantly increases health risks in the laboratory environment.
So, to prevent the accidents, there are a few of control measures when checking the transfer of chemical. First, we have to use the fume hood. The second one, we have to wear the goggles. And we also have to wear gloves and follow the SOP during the transfer of any chemicals. And also, we have proper chemical storage for each of chemicals that we use. So, based on the video, always remember, use the fume hood, wear goggles, wear gloves, and wear respiratory coat when transferring HCl. And also, we have to have a proper chemical storage with clearly labeled, fixed storage space, and any incompatibility found, we have to segregate that. Thank you.
In conclusion, concentrated HCl is always a hazard because it's corrosive and it can produce harmful vapors. When the bottle is safely stored, the risk is very low because there is no exposure. The transition happens when the students carry out danger actions, for example, bypass the fume hoods and pour the acid at the open area. This will cause the harmful vapor to be released, create exposure to the nearby students. Throughout the process, the hazards of the acid does not change, but the unsafe human actions create exposure and the exposure turn the hazard into the risk.